Hey everybody, it's Jenny from Norman S. Wright. So last week we talked about belt drive and direct drive fans. So let's continue on with fans this week. Let's talk about fan configurations and arrangements. Let's get started.
AMCA Standard 99-16 defines the different fan arrangements. The arrangement is basically the orientation of the fan drive to the fan housing and wheel. It basically defines the way a motor drives the fan and how the motor mounts on the fan. Before we get into actual arrangements, let's quickly cover SWSI and DWDI. SWSI stands for single width, single inlet. It means that the air flows into the fan on a single side and it's a single width fan. And so it would kind of look like this if you're looking at the discharge end of the fan, with the airflow coming into one side. Let's put some labels to this because I'm going to use this view of the fan for the rest of the video. So the housing or casing is the outside of the fan. This opening is the discharge opening of the fan, and then you're looking at the wheel in the fan, and this would be the bottom half or so of the wheel. DWDI stands for double width, double inlet. It means the air flows into the fan from both sides, and it's a double width fan. For any given fan wheel size, RPM, and pressure conditions, the DWDI fan will have double capacity of the SWSI fan. The DWDI fan also allows for better balance of airflow into the fan, which can result in improved performance and efficiency. DWDI fans often have a more compact design compared to SWSI fans of equivalent capacity. So basically, they're not twice as wide as a similar SWSI fan. So let's slide this over and talk about the arrangements now. In this video, I'm only going to cover centrifugal arrangements. There are also arrangements for axial fans that we can go into later. Arrangement 1 looks like this. It is a SWSI fan. The impeller is overhung on the shaft so that the bearings are mounted on a pedestal base and are outside the airstream. So let's label these parts, and I'll keep consistent with these colors throughout the drawings. So you can see in the drawing that the shaft is on the outside, and it would go into the center of the wheel if you could see the whole wheel. So the impeller is overhung on the shaft, and the bearings are mounted to this pedestal. It can be used for belt drive or direct drive fans, but is most commonly used for belt drive fans. So arrangement 2 looks like this. It is for an SWSI fan. The impeller is overhung on the shaft so the bearings are outside the airstream, but the shaft is supported by the fan casing, not its own pedestal. And I forgot to label the inlet collar on the last drawing, so we'll show you that here. Let's add the notes down below. This can also be belt drive or direct drive, but is typically belt drive. Let's move this out of the way and look at arrangement 3. Arrangement 3 for single width, single inlet looks like this. The impeller is mounted on the shaft between the bearings. So there's a bearing on either side of the fan. This means that the bearings are in the airstream, so this application is more suited for dry air. You can also have arrangement 3 in DWDI, which looks exactly the same except for the fan impeller is wider. This arrangement is suitable for belt drive or direct drive. Next is arrangement 4. Arrangement 4 is for SWSI direct drive fans, and it's probably one of the more common direct drive fan arrangements. It looks like this. The fan wheel is overhung and mounted directly on the motor shaft with the motor mounted to a motor base. This eliminates the shaft and bearings, reducing maintenance and providing the most compact layout. Now let's move this over and talk about arrangement 5. Arrangement 5 looks similar to arrangement 4. The fan wheel is overhung and mounted directly on the motor shaft. The difference is that the motor is mounted to the fan casing itself. This would be used on a direct drive fan. Next is arrangement 7. Arrangement 7 is similar to arrangement 3, except that there is a motor pedestal for the motor. It can be SWSI or DWDI. It's used when the motor is coupled to the fan shaft, like this. Now let's move this out of the way and look at arrangement 8. Arrangement 8 is basically the same as arrangement 1, but has a base for the motor. In this case, the motor would be coupled to the fan shaft as well, and it's for direct drive fans. Next is arrangement 9 for belt drive motors and looks like this. The impeller is overhung on the shaft with the bearings mounted on a pedestal. The motor is mounted on the side of the fan pedestal, typically reducing overall size and installation costs. I'm going to put arrangement 10 down here in the corner. Arrangement 10 is similar to arrangement 9, except that the motor is mounted inside the bearing pedestal. So let's move this over and talk about motor positions. AMCRA 99 also defines the possible motor positions. First of all, the motor location is determined by facing the drive side of the fan. From there, the locations are designated like this as W, X, Y, and Z. And let's add this note down here so we don't forget about it. And then one last thing I want to cover is rotation and discharge for centrifugal fans, which is also covered in the AMCA 99 standard. Just like motor position, rotation and discharge direction is determined by standing on the drive side of the fan. On an SWSI fan, this is the side that's opposite of the inlet. On a DWDI fan, if there's a single driver, that's the drive side. If there are multiple drivers, the side with the higher total power is the drive side, and if the total power on each side is equal, then the side that has the fixed bearing is the drive side. There's a bunch of different rotations in discharge, so I'm not going to draw them all. I'll just give you a couple examples. So if the fan is oriented like this, with the discharge facing up and the bearing pointed at you, then this is a clockwise rotation up blast fan. So you'll see CW 360. If it has an orientation like this, and my angles are obviously not going to be exact here, then this is also clockwise rotation, but it is a 45-degree angle. And one more example of clockwise, this down blast, this would be clockwise 180. Now, if it's rotating like this, then this is counterclockwise up blast, so counterclockwise 360. This is going to be a counterclockwise 135, and then this would be counterclockwise 315. So you get the idea. Now you know how to tell rotation and discharge position and arrangements. We'll pull them all back on screen. So that covers fan arrangement and configuration basics. Don't forget to subscribe to our YouTube channel, and thanks for watching.